Azure Cosmos DB is a globally distributed, multi-model database service designed to provide high availability, low latency, and scalability. It supports multiple data models, including document, key value, graph, and column family, making it versatile for various application needs. Azure Cosmos DB is fully managed, meaning it handles database administration tasks such as patching, backups, and scaling, allowing developers to focus on building applications. Azure Cosmos DB offers several key features that make it a powerful choice for modern applications. These include global distribution, which allows data to be replicated across multiple regions, elastic scalability, enabling seamless scaling of throughput and storage, and multiple consistency models, providing flexibility in balancing performance and data accuracy. Additionally, it supports multiple APIs, including SQL, MongoDB, Cassandra, Gremlin, and Table, catering to different application requirements. One of the standout features of Azure Cosmos DB is its global distribution capability. This allows developers to replicate data across any number of Azure regions, ensuring high availability and low latency for users worldwide. The service automatically manages the replication and synchronization of data, providing a seamless experience. This feature is particularly beneficial for applications with a global user base, as it ensures data is always close to the end users. Azure Cosmos DB offers elastic scalability, allowing developers to scale throughput and storage independently and on demand. This means you can start with a small amount of resources and scale up as your application's needs grow. The service provides automatic and manual scaling options, giving you control over how resources are allocated. This flexibility ensures that your application can handle varying workloads efficiently without compromising performance. Azure Cosmos DB provides 5 consistency models: strong, bounded staleness, session, consistent prefix, and eventual. These models allow developers to choose the right balance between consistency and performance based on their application's requirements. Strong consistency ensures the highest level of data accuracy, but may impact performance, while eventual consistency offers the best performance with eventual data accuracy. The other models provide intermediate options, allowing for fine-tuned control over data consistency. Azure Cosmos DB supports multiple data models, including document, key value, graph, and column family. This multi-model capability allows developers to use the most appropriate data model for their application's needs. For example, document databases are ideal for JSON data, while graph databases are perfect for handling complex relationships. This flexibility makes Azure Cosmos DB a versatile choice for a wide range of applications, from e-commerce to social networks. Azure Cosmos DB supports multiple APIs, including SQL, MongoDB, Cassandra, Gremlin, and Table. This means developers can use their preferred API and SDKs to interact with the database, making it easier to integrate with existing applications. For instance, if you have an application that uses MongoDB, you can use the MongoDB API to interact with Azure Cosmos DB without changing your codebase. This compatibility simplifies migration and development processes. Azure Cosmos DB is designed with security and compliance in mind. It offers features such as encryption at rest and in transit, role-based access control, and integration with Azure Active Directory. These security measures ensure that your data is protected against unauthorized access and breaches. Additionally, Azure Cosmos DB complies with various industry standards and regulations, including GDPR, HIPAA, and ISO, making it suitable for applications that handle sensitive data. Azure Cosmos DB is suitable for a wide range of use cases and scenarios. It is ideal for applications that require high availability, low latency, and global distribution, such as e-commerce platforms, social networks, and IoT solutions. Additionally, its multi-model support makes it a good fit for applications with diverse data requirements. For example, an e-commerce platform can use the document model for product catalogs, the key value model for session management, and the graph model for recommendation engines. Developing applications with Azure Cosmos DB involves several steps, including setting up the database, choosing the appropriate data model and API, and implementing data operations such as CRUD: create, read, update, delete. Developers can use the Azure Portal, Azure CLI, or SDKs to manage their Cosmos DB instances. Additionally, Azure Cosmos DB provides features such as stored procedures, triggers, and user-defined functions, allowing developers to implement complex business logic within the database. Optimizing the performance of Azure Cosmos DB involves several best practices, such as partitioning data effectively, choosing the right consistency model, and indexing data appropriately. Partitioning helps distribute data evenly across multiple nodes, ensuring efficient use of resources. Selecting the right consistency model can balance performance and data accuracy based on application needs. Proper indexing ensures that queries are executed efficiently, reducing latency and improving overall performance. Azure Cosmos DB provides various tools for monitoring and troubleshooting, including Azure Monitor, Application Insights, and Diagnostic Logs. These tools help developers track the performance and health of their Cosmos DB instances, identify potential issues, and optimize resource usage. For example, Azure Monitor can provide insights into request rates, latency, and throughput, while Application Insights can help track application-level metrics. Diagnostic Logs offer detailed information about operations, helping in troubleshooting and debugging. Managing costs in Azure Cosmos DB involves understanding the pricing model and implementing cost-saving strategies. Azure Cosmos DB charges for throughput, measured in request units per second, and storage. To optimize costs, developers can use features such as autoscaling, which adjusts throughput based on demand, and reserved capacity, which offers discounts for long-term commitments. Additionally, monitoring usage patterns and optimizing queries can help reduce unnecessary resource consumption, further lowering costs. To illustrate the capabilities of Azure Cosmos DB, let's look at a real-world case study. Contoso, a global e-commerce company, needed a database solution that could handle high traffic, provide low latency, and scale globally. By implementing Azure Cosmos DB, Contoso was able to replicate data across multiple regions, ensuring high availability and fast response times for users worldwide. The multi-model support allowed them to use the document model for product catalogs and the graph model for personalized recommendations, resulting in a seamless and efficient user experience. The future of Azure Cosmos DB looks promising, with ongoing developments aimed at enhancing its capabilities. Microsoft continues to invest in improving performance, expanding global reach, and adding new features. Future trends may include more advanced machine learning integration, enhanced security features, and greater support for hybrid and multi-cloud environments. Staying updated with these developments will help developers leverage the full potential of Azure Cosmos DB for their applications. Azure Cosmos DB is a powerful, versatile database service that offers global distribution, elastic scalability, and multi-model support. Its robust features make it suitable for a wide range of applications, from e-commerce to IoT. By understanding its capabilities and best practices, developers can build high-performance, scalable, and secure applications. The next steps involve exploring Azure Cosmos DB through hands-on practice, experimenting with different data models and APIs, and staying updated with the latest developments to fully leverage its potential.